In this question from the chapter relation, we have to check whether the relation R, whose definition is RAB, where A is less than equal to B, we have to check whether it is reflexive, symmetric, or transitive. And the relation is in R. Here, this R indicates the real number, right? So don't get confused between these two R, where this R is the domain and codomain. Now, in order to check for the functions relation to be called reflexive, what we need to figure out that is A belongs to R for every A, here R is the relation, every A that belongs to the domain, and domain is all real number here. Now, most of you actually take a small integers and you end up doing wrong. Let's say if I take 2 comma 2, you may say that it belongs to R as 2 is less than equal to 2 cube, right? And you may call it reflexive, which is not. Now, as you know here, the domain is all real number. I need to check for the other values. Say if I take half comma half does not belongs to R, as you must be knowing that half is not less than equal to 1 by 2 whole cube. 1 by 2 whole cube is 1 by 8. And in fact, 1 by 8 is less than 1 by 2. So we'll say that here R is not reflexive. This is not reflexive. Now, in order to check for the symmetric, what we need to check that if AB belongs to R, then BA must belongs to R for all A that belongs to the domain, which is a real number. Now, if I take an example here, let's say I take 1 and 2 only. Say I say that 1, 2 belongs to R, right? And this is because 1 is less than equal to 2 cube, right? As 1 is less than equal to 2 cube. But what in case if I flip the order, does it belongs to R? Should be no. Why? Because 2 is not less than equal to 1 cube, as 1 cube is, in fact, 2 is less than 1 cube, right? 1 cube is 1 only and 2 is greater. So we'll say that it is R is not R, which is the relation here, is not symmetric. So we'll say it's not symmetric. Now for transitivity, well, I suppose this is takes a very longer time if you do by hit and trial method. So I remember it as a triplet, and I choose ABC in such a way that, say, A, I took any small natural number, and I take B as half of A. As you can see, A is 3 and B is 3 by 2. I'll take C in such a way that the numerator of C will be the product of these two, that is 6, and the sum, denominator as the sum. Now, when you check for transitive, well, you must be knowing that here AB for transitivity, AB as well as BC, if it belongs to R, then AC must belongs to R for all A that belongs to the domain here. Now for the first part, let's say if I check A and this is B, this belongs to R as must be knowing that 3 is less than equal to 3 over 2 whole cube. Well, 3 over whole cube, like 3 cube is 27, 2 cube is 8. And if you divide 27 by 8, you are getting 3.375, which is greater than 3. Now, even BC also belongs to R. This is B, and C is 6 over 5. This also belongs to R, right? This belongs as 3 over 2 is less than equal to 6 over 5 cube. Now, the 6 cube is 216. When you divide it by 5 cube, which is 125, we get 1.78, right? This is approximately, not approximately, it is exactly terminating 1.728, which is less than, which is greater than equal to 3 by 2, which is 1.5. But AC does not belongs to R. But AC, A is 3 and C is 6/5. It does not belongs to R, as 3 is not less than equal to 6/5 whole cube. So we'll say that it is not transitive, not reflexive, not symmetric. That's what we need to check in this question.